I'm Minegi and welcome back to my channel. So in this video we are going to talk about the longest subarray with sum k, and this problem came on HackWithInfy. So what approach we are going to do is that we are going to first explain the problem here and then we will go to our laptop and write it in Python. So let's understand the problem first. So we have k equal to 7 and we have an array. What is k? K is equal to the sum that we want to achieve. And the array is basically 3, 4, 2, 1, 5. In this array, we need to find the longest subarray which is equal to 7. So if you see here, 3 and 4 is one of the subarray which is 7. Another would be 4, 2, 1 equal to 7. So we can say in this scenario, 4 to 1 is the subarray which is equal to 7. So the answer is 3. The question is now how should we achieve that while writing a code? So what we are going to do in this particular video is that we are going to talk about the optimal solution. You can always try the brute force solution, means checking every combination, and the complexity would be O(n) square here. But let's talk about the optimal solution. In optimal solution, what we are going to do very simply is to have a running sum. When I say running sum means, so if we add the element 1, the running sum is 3. Then we do 3 plus 4, 7. 7 plus 2, 9. 9 plus 1, 10. And 10 plus 5, 15. So this is a running sum. And every time we calculate the sum, what we do is that, so when we are at the first position, we do 7 minus 3 and we get 4. And we see if we have ever seen 4 in our array. So the answer is no. When we are here, we do 7 minus 7. Have we seen 0 in our array? No. When we are here, we do 9 minus 7. The answer is 2. Have we seen 2 in our array? So we are here, but we haven't seen 2 before that. So answer is no. But when we are at 10, that means we are at the third position. We do 10 minus 7 and we get 3. And 3 we have seen in an array, and the 3 appears at the 0th location. So we can say that 3 minus 0, that the index 3 minus 0 is 3, and 3 is our longest subarray with a sum k. Now let's move back to our laptop and write this. So let's understand how we will write the code in Python. First we define our function definition, which is pretty simple. The next thing is to create the dictionary in which basically the first scene will be stored. Now the whole approach hangs on it. The question I answer at every step: have I seen a particular running total before and where? Oh, that's why we look up by value. So we need a dictionary. O1 is for check and O1 is for insertion. The key is the running total and the value is the index. A set won't do because it would tell me the total appeared but not where, and without the position I cannot measure the length of the stretch. So that's why we are going to do with the dictionary. The other variable which we need to initialize, so for scene is equal to, let me create an array, a dictionary, and then the next scene is the max length and the current sum, right? The max length and the running total. You can call it a current sum. The rest is pretty simple. So we go like for I in range length of our array, and we close the bracket, and then basically we calculate the running total. How do we calculate the running total? By whatever we are getting in the current index by adding it to our running sum, or we can say our current sum. Now the next step is basically to the lookup. Let me first write the code to explain you what's going on. So what we are going to do here is that if the running total, so before the lookup, actually, if the running, or we say if the current underscore sum is equal to k, we basically say this is the max length. So this is what we are going to do first. And the second is basically our lookup. This is also, as it's a lookup, the complexity is O of 1. And if the running total minus k is the key, then some earlier position definitely had the total. So everything since the sum of k, I stored in the index straight out, and the length is just I minus that index, no scanning. That means what we are going is 0 minus 3. The last if is basically is for it stores the index as a value only on the first time I see the total, never overwrites it. For a fixed current position, and a smaller stored index means a longer stretch. So keep the earliest occurrence guaranteed the longest answer. This is why the value is the index and this if guard matters. And that's why you don't want to pull the else here, you want a if here. So this is a code. I hope you are able to understand this, and this will work in basically the complexities of n, the spaces of n. If you have any doubts, please feel to write me in the comment section, and if you like the video, please give it a like. But thank you so much for watching this video, and see you.